Hello, everybody. Today, welcome to, chapter 4 of geometry. So, this is going to be our last lesson that will be on all the definitions and postulates and also theorems before we start actually doing proof. So, let's just go ahead and learn the last of the stuff. And then afterwards, tomorrow, we're going to go ahead and start applying them so you can see how the statement and reason thing actually works out. So, in this section, or in these two sections, we're going to be talking about the following over here. So, number one is going to be just a quick note on about angles, which we learned in the last section. And also, the second part will be some formal definitions of like what kind of angles there are going to be. So, here in our first example over here, well, this is not really example, but this is a quick clarification as to what we've been dealing with so far. So, in this chapter and also the last chapter, we talked a little bit about how to define an angle and what is it going to be and what is the numerical measurement of the angle and so forth. So here in this case, we have two examples of angles right here. So in the left right here, you'll notice that we have angle CAB. So you call them by three letters. The middle one is going to be the vertex of the angle. And then the other two letters are going to be points that are on the rays of what they call the sides then. So in this case, since we call it CAB, then that means that I care about like the direction of the angle. Where is it actually going? So in this case, for angle CAB, what I'm saying is over here, and I kind of drew it wrong over here, so hopefully you can forgive me for it. We are going from this side over here, CA, all the way to AB right here. So with that being said, then what is known is that the initial side of this angle is going to be CA right there. And I guess we can go ahead and call it CA the ray because that's going to be our initial side. Whereas the terminal side, meaning where does it end, is going to be AB, the ray over there then. Okay, so there's an initial side and then there's a terminal side depending on how you're going to rotate it. Now, for the next example, for angle PBJ right there, you are going to have the same thing. So let's go ahead and change it around this time around because we did it the other way around earlier. So let me go ahead and change it up, okay? So let's say in our example over here that we are going to do a rotation that is going to be counterclockwise. So in this case, for angle PB and J, not PB and J, PBJ, this is going to have the initial side, which is going to be BJ the ray. And then whereas the terminal side is going to be BP the ray then. Okay, so that's just something quick to kind of clarify. Now, in terms of all of this that I've been talking about so far, we won't really see too much of it, but we won't see too much of this being implied into the geometry that we're going to be doing, but we will see it definitely in trig and also pre-calculus. So this is just kind of like an introduction to it. And here are these two last things from the same concept about direct angles. So here you can see I have a straight line in this case with 3 points. And what I did was I defined certain angles according to them. So we have the first one over here, which is the measurement of angle RTS. So it goes from R to T and then S. So if you are going backwards straight like this, all on a straight line, then we can say that the measurement of that angle in between those two rays, the initial side, terminal side, is going to be equal to 0. So that is going to be 0 over here. So that's 0 degree. Whereas if I say TSR, so you can see how this works out, when you try to draw it out this way, then that means the angle is going to be 180 degrees. Again, in geometry, we don't really care too much about like the 0 degree or the 180 degrees situation because we only care about something that forms actually an angle between 0 to 180 exclusive of the endpoint. But again, after we're done with geometry and we deal with like a higher degree math, then we're going to care about those, okay? All right, so here's the last part of it. These are the last formal definitions, and then we're going to go straight into like the proof stuff, as we said. For any angle, we'll go ahead and call it MVP. We can define that as a right angle if the measurement of MVP is equal to 90 degrees. Then we say that the angle is an acute angle if the measurement of the angle is between 0 to 90 and exclusive of the endpoints. Whereas the angle will be considered obtuse if the angle, the numerical measurement of it, is going to be between 90 to 180, and again, exclusive of the endpoints then. So you notice we covered pretty much every single situation then in that case. Then going back to the last chapter or last section, we talk about supplementary angles. We say that if B and A are considered supplementary angles, then that means that the measurement of the angles, the sum of them, is equal to 180 degrees. Whereas if the measurement of two angle with sum is equal to 90 degrees, we go ahead and call them complementary to each other. And finally, for the last one is the idea of congruence. So if you say that two angles are congruent to each other, then that means that the measurements are going to be equal to each other. So you can interchange between the two like so if you wanted to. All right. So here's just some quick questions to kind of think about, and then we're going to go ahead and end it just to test your understanding here. Number one, how would you define two rays that are going to be perpendicular to each other? Well, if we were to draw this out, because I think that's the best thing we can do for any kind of algebra geometry problem, two rays that are going to be perpendicular to each other like this, and I should say by the endpoints, are basically going to form a right angle. So I guess one thing that we can say is that those are going to be the sides of the right angles then in this case. So those are going to be the sides of a right angle then. Okay, so you can see this guy right here and this guy right here. Those are going to be the sides. Next, if two lines are perpendicular to each other, then they form how many right angles? So in this case, we have a line, right, meaning it goes on forever, and they're going to intersect each other, and like so. And as you can see in this picture, they're going to form 4 right angles then. And finally, for the last part, if AB, the ray, is going to be perpendicular to AC, the ray, so meaning it looks something like this over here. Here's AB, and then here is AC. Then the conclusion about AB, the ray, in comparison to AC, the line, well, it looks like they're going to be perpendicular to each other as well. And finally, for the last one, if AB, the line segment, is going to be perpendicular to AC, the ray right here, or actually AC, the line. So here's A, and then here's C, and then here's B, right? If this line segment is perpendicular to it, then we can say that AB is definitely going to be perpendicular to the entire line of AC. And also AB, the line, is also going to be perpendicular to AC then. All right, thank you so much for watching. I will see you next time then. And so hopefully we'll be prepared. All right, later on.